All right, why don't we go ahead and get this started? So first thing, thank you guys very much, everybody, for taking the time out of your day to come and listen to this esteemed panel of experts. My name is Tracy Markey. My day job is CEO, founder of Ingenuity Systems. We're a VAR and more recently a software producer. And have been involved with integrating AI into our platform. So this is a perfect fit for me to learn a whole bunch about AI because I don't create it, these guys do. So we should, this is a really unique opportunity for you guys. These are 4 leaders certainly in our industry in the AI field. So be thinking about what is the one question you always wanted to ask an AI expert. You've got a panel full of them here today. Just to kind of kick things off a little bit, also thank you on behalf of automatedbuildings.com. I appreciate that. If you go into an AI-supported platform like Adobe and you ask it, what does the future of commercial buildings look like with AI in it, you start to get images that look a little like all of these. And the reality is, who knows for sure what the future looks like in some of our stuff. And hopefully we're going to discuss that today is very much about what does, the next event horizons, whether that's 3, 5, 10, and maybe even we'll get into what does it look like 20 years from now. Certainly at the center of it all, though, is going to be some form of AI technology. And one of the questions that we'll start out with early here is maybe a little explanation of what are the different kinds of AI out there. So these guys can talk a little bit about that. The other thing that is a definite reality in our industry is it's right around the corner for us, and it's right at our doorstep, actually. So we're starting to see applications utilize AI in central plants and RTUs and all kinds of different, anywhere where they can get data access, they're starting to apply different techniques to that. So it is here, and there's no stopping it at this point. And I personally am very curious of what the future holds for us, and that's what I'm hoping to dig into a little bit here with this panel today. Just for those who came in late, the fire marshal has asked us to minimize or eliminate the standing in the back of the room. If you guys can try to find chairs, I'd appreciate it. I know it's a pretty full house here, but thank you. We won't bite up front, and now we're filled up at least, so that's pretty good. All right, so let's jump right into it. So the format today, I'm going to let if I read their bios, we would literally be here for the next 45 minutes. We have quite a set of resumes here, so I'm going to let them talk about themselves. And we'll go down the row with introductions, and then I'll kick off a couple of questions to get the conversation started. If there's a burning question that you have, we have a microphone in the middle you can step up to. Otherwise, I am leaving a big chunk of time at the end for an engaged conversation with everybody. So be thinking about the questions that you'd like to ask, okay? So we'll get to it one way or another. All right, without further ado, Danielle, why don't you kick us off with the introductions?
Yeah, my name's Danielle Radin. I work for a company called Facile.ai. We do use current AI agents to optimize central plants and rooftop units, and we're expanding into any other mechanical system. I come to this industry as a scientist, a psychologist, and a storyteller. I'm not an engineer, so I have a very different perspective, and I might be on this panel to answer the question of, is AI taking our jobs? And how do we have to change as people and users of AI? Just because my background isn't about the math. I really focus on the people and how is this affecting us. And then next in line is Troy Harvey.
Yeah, so I'm Troy Harvey. I'm the founder and CEO of Passive Logic. You may have had an opportunity to see our booth this year or prior years. We're bringing what is substantially the first new automation platform to the industry in the last 20, 30 years. And that's all built on a premise of AI. So we started not too long after OpenAI, so long before the public was talking about what is AI. We understood that automation in buildings is the world's largest and most complex robotics problem, right? And so I think this is something for us to get our head around, that infrastructural robotics, the things that are bolted down to the ground, are actually far more complex than, say, a humanoid robot or an autonomous vehicle. And we understood that we needed to solve this, and the only way to do that was with AI and full autonomy. And so in our company, we have people who are working on control path pipeline AI, physics AI, deep learning control policy AI, digital twin construction AI, and these, what we call GraphRag, the ability to interact with a language model that interacts with a larger, context of your digital twin and can answer those questions without hallucination. So there are a lot of different parts of this problem, and I hope we'll have a chance to talk about, how those different pieces interact with you.
Thanks, Roy. Brian Turner, I'm a bit of an imposter on this one. I don't make technology anymore. But I do implement it. So we're a controls contractor, master system integrator, and services provider. And because I did spend a good part of my career making software, I definitely recognize the value of AI, specifically right now, machine learning-based AI. And I think that using AI tools, like many of these people make, and several of you in the audience, to provide better services to facility owners and the building owners is the now and the future. And so I'm excited to be up here and happy to talk from that perspective. Andrew.
All right. Etcher Dema, I'm one of the co-founders of Code Labs. We started Code Labs in October of 2017 with kind of more the mission to bring data from local servers and then connect it also to cloud IoT solutions, which is what we kind of saw as the opportunity to bring in all-in-one, where you can actually start to do different use cases, whether it's AI or other, client-centric use cases that we thought would have an opportunity to build a model where, you can start to run different strategies on per square foot from a commercial perspective, and then different strategies from retail and others, but really configurable so they can combine them all, where we can start to do AI, ML, and other things that we believe it's what's needed.
All right, thanks you guys. Thanks, Edrit. Let's start out with some definitions. So in our discussions leading up to this, a few of you have mentioned, they're really kind of different AIs, but people generally lump them all together. Somebody want to comment about, what's the difference between some of the AIs that we're starting to see applied in our industry? I'll just open it up to whomever feels.
I'm happy to start with that one. I think if we look over the last 2 years, it's the growth of language models, right? This is what people are all experiencing, right? And what's important to understand about language models is that is just trained on words, right? Just trained on scraping the internet of all of the words, the articles, the papers, the books that we put on the internet. So what's really important to understand about the AI you're experiencing when you use ChatGPT or DeepSeek, that's really fluent language models. They are not intelligent. It's interesting to understand the difference between fluency and intelligence, and actually how fluency can mock intelligence, right? It can appear so intelligent because it's so fluent, more fluent than any of us, but it's not intelligent in any way. One thing to understand model-wise from our industry is, why are language models leading the way? It's because they're easy. People have spent thousands of years putting words on things in lots of languages. We've spent the last 30 years tossing all those words with a billion people, billions of people contributing onto the internet. You can scrape the whole thing and make language models really easily. There are thousands and thousands of different use cases for AI. And you're seeing that language models are taking the sort of pole position in people's mind's eye. It's because they're easy, and therefore there's a lot of them. But we have a lot of different use cases for AI, whether it's control, whether it's how do we talk to different kinds of protocols in I/O, whether it's like working on visualization, all these different problems in automation and buildings and industrial systems. They're different from ChatGPT.
I can talk a little bit about how we've used machine learning using the same thing where you're training the data. And when you're integrating buildings for 20 years, you end up with a lot of data. We've got a lot of data in our cloud environment where we can actually use that to predict what's going to happen. We can also use it to understand if there's a problem happening that maybe humans can't interpret yet. The difference with it being intelligent, to Troy's point, is we still have to have a human actually review those results. Because while we may get 85% accuracy on most everything that we have, it's still 85%. And you don't want to make meaningful decisions on 85%, but you can review them, validate them, and then when you validate them, that actually feeds back into the model. But we're not talking billions. We're talking billions of rows of data, but not billions of different examples, right? You're talking maybe thousands still. And so our industry and the amount of data we've collected is still very young, and the siloed characteristics of our industry where, I have building data for my clients, and Troy has building data for his clients, and maybe the big owners have all of their specific building data. There is no repository of the thousands and thousands of buildings and all of the data they've collected for the last 25 years. And if there was, we'd be a lot further on.
Sorry, quick question.
Yeah.
So just as a point of reference, because I think it would be really helpful, AI is doing 85%-ish accuracy on its diagnosis. How good are humans, just as a point of reference?
Yeah.
Can you repeat that?
Yeah.
Brian?
Well, yeah, so the question was, if the machine learning is 85% accurate on predicting problems, how does that compare to humans? I'll just say it's better, because humans can't process all of the data that it's processing. So, when I look at just a simple rule, and I'll just call it rules-based because it is, I'm going to look at historically the last 55 Mondays when outside conditions were this and indoor conditions were this and my overall energy demand looked like this. What was the result, right? A computer can process that in nothing flat. A human can't, but the human did come up with the question to ask, right? So we had to design the rules, but then you're able to use the machine learning, the AI, to help inform.
And humans coming back in at the end of the diagnosis.
Correct.
To do a reality check?
That's what we're doing. So that's that managed services that we do. So we use tools like these guys create in order to inform our engineers, who then will make decisions based on that data. So they're not sitting there mining thousands and thousands of spreadsheets or creating their own stuff. They're getting the results from these tools, looking at it, interpreting it, and then making decisions.
I think one thing to note too is we're very, very light on AI when it comes to our buildings right now, regardless of who we are, what we're doing, because there's just too much information in buildings and data that's still, you can't it's too dysfunctional when you think about it. It's not because humans did it wrong or did it right or anything else, but when a building, regardless of what type it is, when it gets new constructed, to how it gets turned over, to then how the floor retrofits happen for commercial larger buildings, to then retail, to others, there's still some work to be done. And then also on top of that, when we think about AI, right, we can only go so far with it right now. You can only go so far, because anytime you pull into buildings, you will find missing either data points or missing information. And when you try to go back and go into that information, that's when it can get a little bit cloudy. And I think we need to solve for that a little bit more, define these profiles to get there.
Adding on to this, to your question, I think these guys made a really good point, right? And is when you think about in language models, which you've now used, people talk about hallucination. I don't actually think it's hallucination. How often do you talk to your employee and you spend 15 minutes explain something to them and you get the wrong answer, right? And how well can you in ChatGPT misspell it and do it in a sentence and a half, and it gets really close and you have to say, no, let me give you 2 more sentences. It's actually really, really good, right? So the 85% or getting that refinement, I don't think there's any real differentiation between what is the difference in way humans behave and what the way AI behaves. Couple of important points here, though. When we think about I think what Brian was bringing up, there's key issue here, that's the siloing of data, means just that we have to have a different approach in this market than just like, oh, we have thousands of years of building data from all the buildings and all the contexts of those buildings to go build super generalized deep learning models that are working in the exact same way that a language model works, which is why at Passive Logic, we took a different approach. We said, we're going to take deep learning, we're going to put it on top of digital twins to solve this problem that we were just talking about, that if you don't have the context for the building, right, you can't take an existing, say, BMS. This is why we started from scratch. Think of a BMS, it doesn't know anything about the building, right? It's like a giant black box filter for that information. Yeah, it knows backnet points. It knows, that here's like some kind of algorithmic curve for how you're adjusting to the control, but it literally knows nothing else, and so you're not going to extract something for which it's not there, right? And so if you really want to get to these smarter systems, you have to start with a different premise.
Another thought too, my background is actually in neurobiology. Humans make mistakes because mistakes are efficient. We can run on habits. I know you know this because I talked to you about these books. And so as we become more and more efficient, and as we want to make our data centers more efficient, and we want to make AI more efficient, we almost have to build in those mistakes, but also build in the metacognition for the AI to go back, look at those mistakes and say, oh yes, now I know how to fix it and learn from their mistakes. And that's how we build our AI agents to be more self-sufficient and more intelligent. So having a few hallucinations early on is how we're going to grow and develop AI into the next 5 years, into the next generation.
We certainly have all heard the phrase, we learn from our mistakes, right?
Exactly.
So, I want to take a minute and kind of hear all of you talk a little bit about the state of the industry. Where is AI being applied effectively right now? Let's kind of set a ground level for where we are today. So Danielle, why don't you go ahead and start?
Yeah, so we have actually implemented AI doing 100% autonomous chiller optimization. We've completely eliminated the need for a human in the loop. And the reason we were able to do that is because we gave it a very specific target and we set clear boundaries. So we said, all right, this is your box, AI agent. This is what you can run with. These are the points we're going to give you. Make this chiller more efficient. And we've actually gotten a coefficient of performance of almost 20 at points. I mean, compared to the AHR standard, we've been able to outperform even the best as far as chiller performance. Now that's saying this is a very specific AI agent. There's so much more capability to go from there.
At Passive Logic, we've been really focused on generality, right? So I introduced the idea of autonomous vehicles or the idea of humanoid robots, right? So the thing that, as we hire into Passive Logic, when I go to somebody who works in the autonomous vehicle industry, or I go to somebody in the robotics industry and I say, buildings are way cooler than what you're working on. Let me show you. Every building's different, right? So that's the unique thing that you guys are all working with, is that when you do an automation system to control the HVAC system or the energy systems, or now maybe some renewable systems, maybe you have energy storage, maybe you have industrial systems within there, what you're seeing is all of these different points of control. Buildings are what we call a systems of systems problem, right? A car is a system. A building is like having a fleet of cars that you're trying to organize to navigate through the streets from point A to point B all simultaneously. And so that's a really, really interesting problem. So that generality, Passive Logic's goal is to deliver you guys full level 5 autonomy. We have released today a level 3 autonomy to our end customers, and we have in beta level 4 autonomy. Why is that useful? Well, we often talk about the end of the problem of making things more optimal, more efficient. And that's interesting, right? It's better economy. But what we're really interested in is how do we get it done right in the first place, right? People are struggling to get systems actually deployed that deal with all the complexity that people have. And how do we get from, after decades now, the big automation companies have managed to only penetrate, less than 1% of buildings? That's like pitiful after decades of work, right? So how do we get it into all buildings? And so I think that's the real work to be done, and that's what we've been really focused on in the last little bit.
So I'll talk about the actual built environment. It's interesting to talk about what buildings could be if we build them, smart from start and all of those kind of nice keywords or acronyms. But when we're looking at the existing building stock, we have to live with what we have. There's not one owner I've talked to that says, yeah, I'm ready to rip out everything and put in something super smart. They all need to transition. They need to make maybe a 5-year, maybe a 15, maybe a 20-year transition. I don't know if they have that long, but that's their kind of outlook. And so where we've been able to deploy it is really in the ontology and identifying what everything is, what it is, what the points are, how they relate to each other, tying it in with the digital twin if we have one, or enabling a digital twin after we're done. And that machine learning is very possible because it's very similar to a language model, right? So zone temperature has 87 different ways that a technician might call a zone temp. Well, if we know what those 87 are, we can very clearly identify as the same thing every single time. And what's nice about that is that then you start to enable applications like Facile, like Code, like Passive Logic, as they're working with the built environment too. They can't just ignore what exists. So the more of that stuff that happens on the data onboarding side, the data modeling side, the better we are. And we're definitely, I will say, I spent the last 4 years of my life prior to selling our software company building that onboarding. And so we were onboarding complex buildings in less than a week with all of the data modeled into a common ontology. And I think that's a big part of how it's being used today by several different organizations. It would be great if everyone was using the same ontology, but that's I think that's a different seminar. So
I think, so from our perspective, what we've been able to do, because we've been cloud first from the beginning, so we've been able to gather this data in a multi-tenant perspective, but still have anonymized information that could go back, and we've been learning from it for a long time. So what we really wanted to get to, and where we want to get to by the end of this year, more and more, is I got a building or I have a portfolio, and one of our partners is looking to deploy there. They're going to know very specifically that within this location or within this area, if they know at least 5% about that building, they're going to know how to get to that 80 or 90% to be able to, to profile that building. So what I mean by that is, right now, if somebody comes in and says, I have a portfolio in New York, we very quickly tie it down to which regional service type of solution, proprietary, non-proprietary it could be, to then, once they give you a little bit more information, very understand, like if it's a system or whatever the case it is, what type of system it is, we have a pretty good idea of then telling you, okay, if it's I'm not even gonna use the name, but any kind of like BMS system, we already know that there's only 4 providers that service that system, right? Because we have that data, that information. And then if it's one of those providers, or as you get a little bit deeper, you already have a pretty good idea of what's happening there. Then you can quickly tell that, hey, with this provider, generally they program this way, or they do things this way. And this is the kind of things you typically find. So like I can use a Johnson as an example, a Siemens and most others. So we will know what to look out for. And then where we're implementing a lot more AI, and it's working pretty well, is obviously ontology is a big deal. You have to profile these devices to actually know how to enable the applications later faster, because you profile them all different ways, because somebody thinks FCU is maybe a heat pump or something like that. Whatever the case is, then you don't get the data that you need to get out. So at the implementation stage, we are obviously open enough, but we're it's a direction based, where what used to take 500 clicks is now taking 20 clicks, right? So you use AI, Gen AI, and then start to use more agents to then bring that time down. Because if you bring that time down, the big cases for 2025 are, what's my ROI, right? If you can bring that time down and visualize that, look, your building has all these problems already, we already found them, right? What do you want to do about it? Then, because everybody's adding more sensors, more sub-meters, and all these kind of things, how are you going to set up a structure? And where we're using AI next is setting up that structure where they can, with the same kind of data sets, they can do different analytics for different locations or even different floors at times because they have, different use cases there. But then at FDD, Gen AI plus AI agents at digital commissioning, and then we're looking to remove dashboards as much as possible. So like dashboarding is a thing of like no one gets it right as you're going to get it, right? Because everybody wants to see something a different way, and the more opportunity they get to make customizations, what I want to see, you probably don't want to see, regardless if we're looking at from the same perspective. So our goal is where we're seeing a lot of AI come into play is when you have BMS data with occupancy. It's still very hard to say there's this many people in this room, change the temperature, right? Like realistically, it's kind of, doesn't create the best experience, but you can start to do a real Gen AI search to get your data faster about your historicals, about different ways of like scheduling and all this stuff happening. So these really good humans who run buildings and really care about their buildings, because they've cared about their buildings for 30 years, right? Like you're not going to replace that brain, but you can take that brain and turn that brain into a way to operate double, triple, quadruple those buildings, and then start to bring a new type of model, because the younger people that are coming in the industry, they're not the same type of backgrounds that have came in the industry 30 years ago. So you start to combine these together, and we believe that we can really drive towards the roadmaps of AI agents for different reasonings, and then get closer to autonomous buildings, because look, we can get to optimizing how the building is turning on without any touch, right? But in different locations, different areas, there's different rules and laws that we have to abide by, whether it's your union laws or others. So there's plenty of places where I think you can start to do great with AI, but you need to understand those areas and the data behind how these people are doing the programming and everything else. And
we're going to come around a little bit more to the future. I want to save a good chunk for that. So what I'm hearing is not a significant penetration into the market, sort of application-specific uses of various AI technologies. Talk a little bit about the barriers. Why isn't this industry adopting this faster and more deeply?
I'll go again. It's starting to adopt it a lot faster because you're starting to see it within governments, and governments are making a different kind of push, right? And whether they're, most governments are looking at how to implement more AI, and then also they're all leading to how can I cut more and more costs, right? So there's many different ways to do that, but you can take data from what you've had in your servers within buildings, and then by the end of this year, start to actually do more with it by just having it on the cloud. And this is where we're at, right? We still have a lot of data.
Let me interject a little controversy here in this. At a dinner last night, I had an interesting conversation with some governmental and AHR people who have said they're not, in all the papers and standards and so forth they're writing, for instance, let alone the building data, they're not allowed to use AI on any of that stuff. So as you're going through thinking about what are the roadblocks here, maybe talk a little bit about why people have that mindset. Not just you, Eddie, but the group.
So he called me Eddie.
Yeah, I know. Brian got me started.
I told him it was easier.
Eddie.
Don't worry, it's the same thing. We're pretty bullish on, obviously, AI changing more and more with different administrations that are coming along. But as far as using AI for the specifications that are in place from governments today, most specifications from governments like ASHRAE G36 and many others require different applications to be ran at the same time, right? So for that same data, because they don't just require you to do a specific rule, but they want you to take a rule with a digital commissioning with other things, right? So I think as people get to building those advanced workflows, we're really bullish that AI is going to become a bigger and bigger thing by the end of 2025.
Yeah.
It sounds like you were saying that AI is going to optimize the human's tasks.
Yes.
Not really take over the building. There are some people, I think, that think AI is going to run the building. but really what you're describing is optimization of the human's tasks to make them more efficient.
Yeah, I think that, so just to repeat so everyone can hear, what the comment was is this sounds a lot like AI automating human tasks more efficiently, faster right now, as opposed to making an autonomous
Yeah,
building.
I think this is a really important point. When we talk AI and you walk along the floor and discussing AI, there's AI in different levels of the tool set, right? So most of what you hear is AI optimizers, right? I'm doing all the stuff I did before, and I'm throwing an optimizer on top to improve the system, right? That's very different from AI that autonomously is controlling the building at the building's edge, like truly autonomously, right? And those are two different categories, and then there's other dimensions of AI that's talking to our I/O in all the different protocols and languages, and AI that's communicating in more human terms or in graphical or analytic terms. I think one of the things that these guys brought up, and it kind of links together with what you're saying, what are the impediments? Like on the customer side, I don't actually think there are many. There's an adoption curve, right? They will have front runners and you'll have slow adopters. But I think the difference between 2 years ago, prior to everybody using ChatGPT, and now, is it is the future. Everybody knows it. There's very few people that I run into are like, oh, I'm not adopting AI, I'm afraid of it. They're like all using it now, right? And so that's over with, right? We're not like having that discussion anymore. Whether or not ASHRAE is going to come along to like realizing that it's not like we're going to make a bunch of standards around how to program a VAV box, and that's going to be like, we're going to work on that for years and years, and then say that now you guys should put fixed program in your VAV box that meets this specification as opposed to a more engineered standard that can use a lot of different AI, ML. Like, we maybe have to get with the times in terms of standards creation, or at least enable that there's always an engineered path, right? Like, there should never be just a prescriptive path. But I think one of the things that, to the question prior and to what these guys are bringing up, is the missing ontologies, right? And so, as many of you know, we've invested very heavily in a digital twin standard. And the reason is, when you want to talk about how to get from that 85 to 100%, is that you need to have something that grounds your AI to reality. In our case, we decided, what is that ontology? What is that decision? Like, there's thin ontologies, things like haystack, which is tagging, brick, which adds a little bit of like description around the systems. But like, then there's grounded ontologies that say, like, what does this mean, like, fundamentally? And we decided at Passive Logic that was physics. And physics could always fundamentally ground all the questions I ask. So if you have a chance to perhaps go to our booth, one of the things I'm really excited about this year is this thing called Cortex, which is taking LMs and grounding it to the ontology so that every part of the chain of thought it makes, it has to prove itself by the physics. So now you don't have hallucination anymore because it's answering within what can be proved within the physics ontology. And it can answer very deep questions very, very accurately because you no longer have that LOM freestyling. So you have to think about what is AI that's deterministic AI and what is AI like LMs that's non-deterministic AI. But if you bind those together, you can get the best of both worlds.
Another huge challenge that I've noticed is the difficulty of implementation. I mean, the other three panelists are talking about we need ontologies, we need standards. Right now, we're facing a situation where there are companies and solution providers that are building AI, but we don't have streamlined implementation yet. And that's where once we cross that hurdle of saying this is true plug-and-play AI, it's easy, all you do is turn it on like you plug in your router into the wall, that's where AI is really going to take off. We have the solutions, but we still have too much stress and traction to get it over the line. We have to talk to our CEO. We have to talk to IT. We have to get all of these stakeholders on board. We have to build an ontology or purchase an ontology, set it up, go through that process. Maybe that's a whole nother AI agent that we have to involve. So right now, we're still facing this situation where to get the AI implemented is too big of a hurdle. I think that'll change within the next year, especially within the next 5 years. I think that the people on this panel are going to be a huge driving force for that.
Can you talk a little bit about fear, right? Most of the adoption issues I've come across in the customers we work with is fear. And some of it's grounded in reality, and some of it's grounded in Hollywood, I think, more than reality. But there is a human factor here where, I heard the customer say, I'm worried, my chiller's going to go open loop on me if I turn this thing loose.
I was hoping that's where Danielle was going to go, and she just left it alone. So I'll talk a little bit about it.
I was just leaving it for you, Brian.
So when my old CTO, when we were talking about implementing machine learning in our software, and he was taking longer than I wanted him to take to implement it, and his point was, the problem with AI is that it can be confidently wrong, which is something Troy described very early in the session today about it will, because it's more fluent, it will make you believe that what it just came up with was 100% accurate. And it's probably not true most of the time right now. And it doesn't matter if you're talking about a chiller plant or what you should have for breakfast today, right? It's not going to be 100% accurate. And so that does drive fear in, let's face it, a largely conservative industry with a very, very strict mindset around how things get done and how things should operate. And so we have to break down a human factor in this industry because humans are still making the decisions on whether or what not to deploy. And so that is the biggest barrier. I don't think in just about everything we talk about today, from any technology all the way up to AI in this industry, we're very rarely talking about we don't have the technology available. Like, that's not the problem anymore. That was a 10-year-old
I agree. That's what it seems to
right?
me.
This is now just adoption. Are we ready to? Are we willing to? Do we have the cash flow to? Do we have the vision to? I mean, there's lots of things now, and humans are at the center of it.
Let me add to the fear factor a little bit. Not only are we afraid of things being wrong, and anyone who has never challenged ChatGPT on an answer, I ask you to try that sometime. Just tell it you're wrong, and it will say very confidently, oh, you know what, you're right, I missed that, let me do it again, right? So there's that part of it. But what I hear a lot of the fear is, well, where does my data go? Who am I training? What about the intellectual property of all of this? So maybe you guys talk a little bit about that.
I can just start. I think the fear is when you look at where does my data go, like for the longest time, the most, I think it's like a consultants and then obviously like the engineers and the others, they still work on older documentation. So without even asking the corporation or anybody else, they completely assume right away that some things need to be done a certain way. And then when you get a little bit further along, you kind of realize that, oh wait, no, they actually want something completely different, right? So I think that's the first fear. The first fear is we actually have a lot more work to do right now to come back to reality and to come back to what technologies exist. And then the second fear that we see is, from a robot perspective or anything else, your local decision maker is going to start to get centralized more and more, because when you have big data to give better information and to actually decide based on like real data, then the local decision making to come back to make it locally, where like somebody just decides to put in a specific server or something else at the building level, it's going to change, but then it's going to come back better. So like that fear is going to go from, here, let's bring all this to the top, because every large corporation, whether you're Honeywell to Microsoft to a really big real estate company like CBRE or others, they all have data warehouses that they're trying to do this with, right? Because there's actually not enough people anymore to decide these things because it's gotten too complicated. But when you actually start to normalize that, then it's going to give that power back to the right type of profiles locally as well, to then start to decide based on the direction of where that company is going. And I think that's like when you control and all this stuff, we know that people are like fearful of that. But in reality, why we think they're fearful of that is this, because they're not going to be able to decide anymore, which also can affect buying, can affect relationships and a lot of other things based on how it's been done in the past, which has kind of gotten us to
Troy,
not a good
you look
place.
like you want
Yeah.
to add something.
I think, we maybe more than anybody have sort of dealt with the flurry of questions as we come in with like a really different paradigm switch. And I'd say in general, we don't get questions of fear. And I think there's two reasons. One is, and I think this is important, that we built products first and foremost for you guys, for installers, integrators, for mechanical firms, not for, oh, this is downstream something for the customer and they're forcing it on you, right? Like we're trying to build you guys the best user experience that you've ever had as an integrator or installer or mechanical company. So first, solving your problems first. This isn't to cause fear. This isn't to put your job out of, be automated away. It's to give you tools that you've never had, that you come to work and you're like, man, I'm not living in 1985 anymore. I'm living in 2025. This is the coolest industry in the world, right? So that's the first thing you do to like deal with fear. Second thing is, and I think this is important both technically and then explain it to people, as we've been bringing in more people from the automotive space, it's been interesting because I realized how much our AI technology stack really shifted the game from the way the automotive people thought, where they were doing pure deep learning AI to drive cars. So this is non-deterministic, meaning you can't guarantee how it's going to behave. And then you have a team that will do safety, or what we often call formal methods. This is the stuff that can be proved. If A plus B equals C, it always equals A plus B equals C, no matter what situation, where you are in the world. So often those are controlling governance systems that check the AI to say, what is it doing? Is it doing what's right? In our world, what we realize is we have to be 100% right? So our control path line does something very different. It makes, with that ontology, that physics grounding, it makes all those formal decisions first in the pipeline. So the first decisions, it says, I will only guarantee that these things must be true. This is how I have to operate this equipment. And here is the path, what we call a canyon or a corridor that must be true. Now the non-deterministic stuff can run within those guardrails to optimize what is true, but it's all guaranteed, right? So there's a very different like control path pipeline. So that's technologically how you solve it, but it also helps when you talk to customers and you show them how it works, and they're like, that's what I actually learned in school. That's thermodynamics. What the heck is the control systems I've been using for the last few decades? They don't work on any of the stuff I learned in school. They're working in the non-reality. This is the reality that I understand, right? And so I think connecting the dots between like, how would you think as an engineer to solve a buildings control problem as opposed to a PID loop or a dozen of them working together, that has nothing to do with the building at all, right? Everybody's always like pulling their hair out with all these algorithmic loops they can't really tease apart because it doesn't flow by the rules that you know to be true.
I'm totally on board with you, Troy. I think fear is an invalid excuse for saying that there's a lack of technology, because everybody in here, I can guarantee, has used a credit card, and you're more than welcome or more than willing to walk into Target and give them your credit card. But there's a sense of security that's been built from the developers. It's built through the algorithms that are taking your credit card information. We trust that our information is going into a secure system, and we understand what the outcome is. Now, we understand that Target is going to send us ads for baby diapers before we even know that our daughter is pregnant. So we are giving them information, and nobody is afraid of it. But if you were to say, oh, it was really hard to get people to adopt credit cards, that's not fear. That's just a slow process of adoption.
Yeah.
So I agree with Troy. If we overlook the idea that fear is holding us back, then we can actually really come up with what are the solutions that can push this industry forward. And I think it's education and making people feel safe.
Go ahead. Question.
Yeah, one of the things that I always look at is, the systems that are broken in the buildings that we're dealing with when we put AI or building controls on them, and then also the operators. And you want these systems to do certain things, but somebody, either it doesn't really work or somebody doesn't want it to work for whatever reason.
So the humans are getting in there.
Because AI probably can solve that problem.
Yep.
Yeah.
Getting the humans out of the loop and out of the way is one of the very first steps, I think. I always tell my team in troubleshooting, go where the humans have been, and that's where you'll find the problems, right? And that's almost true. I want to do one quick thing. I'm being mindful of time here. I want to change just for a second and not run out of time. I want these guys to talk about what does the future look like. 5, 10, go out as long as you feel comfortable talking about, but paint us a picture of what our industry looks like 10, 15, 20 years from now.
The question on the board is, can autonomous buildings become a reality with AI? I think that's a much more complicated question, but my answer is yes. The follow-up question is, should they? And I think what I see is an entire system of AI governance where we find a balance between what AI can and should do reasonably, while still maintaining that human touch, because AI doesn't have empathy. AI does not have emotion. AI is numbers and data. And we cannot completely remove humans. However, AI will be a very transformative force in our industry.
So as I talked about, we started with building the tools that we knew fundamentally had to be in this space, and we built it for you guys first and foremost. But what we've seen over the last couple of years, and what I think is really, really interesting, is some of those big organizations that owns the hundreds of billions of dollars of buildings have started to come to us and say, hey, the world is changing. And we own buildings, but we've been treating them like buildings, and you guys have been treating them like HVAC systems. And they are much more than an HVAC system. In fact, it's maybe number 4 or 5 on the list of when we're talking about automation, what are we talking about? The buildings as the largest part of the world economy, double the size of transportation, right, is a digital platform for our customers that live in that with all sorts of services that want to plug in. And today that's not possible because we don't have high-level APIs. We don't have a general purpose enough platform to be able to not just do the HVAC, but all of these energy systems, all of the industrial systems, all of the business automation that's happening inside that building, because that building is a container for the rest of the economy. Right? And so what they're coming to us and say, we've been treating buildings like assets, like they're investments, like they're gold or they're stocks, but they're not. They're products with customers, and those customers want other products to plug in, and right now they're struggling to put these things all in a building. So what we're going to see is your job is going to stay this fundamental driver, HVAC systems, energy systems. Yeah, that's going to stay, right? It's going to be 100% the building needs that, but your job's going to expand that diameter of what it's going to encompass to include the automation of everything within that building. And those are the conversations, the deals we're signing today are about how do we digitally transform the business of a REIT to really realize what is that whole economy in the building.
Eddie, Brian, what does 20 years from now look like to you?
Yeah, Ettrick can go after me.
Yeah.
So, sorry, I planted that. I told Tracy.
I'm
just to
completely
call me
okay with it.
Yeah. So I think 20 years from now, I do think we'll be fully automated, but my projections and predictions are worthless because 25 years ago, I said building controllers that stand alone without equipment attached to them won't be for sale anymore. And I've clearly missed that. So I think that they have to be, you watch Minority Report 20 years ago or however long that thing came out, buildings were there as a resource of humans, and it was the human comfort, the human element that was prioritized. And I like to think of buildings the way I think about umpires. If you can't remember anything they did, they were successful. And that's kind of how buildings are. But unfortunately, our experience in a built environment is we always remember something negative about it. Yes. And when we can't, that means that we've been successful with AI and all the automation done properly.
Yeah, I think.
Ettrick, would you like to speak?
Don't worry. You can call me whatever you want. I'm happy. It's not too far. It's like this. How we see it is what we're seeing live right now for buildings that are live. Like we're not talking about just like dreams and realities, but like the live buildings and these operators. First of all, there's different types of talents, okay? And then the second part, 20 years from now, what we're gonna see more and more of is a new, obviously like data engineers running buildings, data scientists running buildings more, which is obviously a bigger need for more tech. But the tech is there today. There is plenty of IoT platforms that can plug in many other things, and I'm not even gonna just talk about code, but like it exists today, it's cost effective, you can find it. What the next version of this AI thing is, when we talk about directly system integrators and everybody else, is we have to have like we're gonna see a more, hopefully, a more strategized base, like how you're doing your programming, and less using just the different types of human experiences brains, but really more like you're gonna be like being competitive in other areas, right? Because how you're programming buildings today is just different. It's just different, even from the same company. So I think we're gonna see that future completely change, because hardware is gonna have to get smarter, and the hardware providers, which we're already seeing, right? So like the BMS that exist today are good BMSs, they work. But what we are seeing too, as you kind of notice from the publicly traded companies, they're making a different play. So they're splitting, they're strategizing, they're doing different things, because they know that if they do what they've done today, then it's not going to work out for them. And then hardware and like low voltage versus obviously like the different controls companies that are out there and the system integrators, it is going to shift. And then that shift is going to be different. And then the services are going to be more digital, right? So like a huge need for technology, and a really, really big need to start moving into like what we're seeing as reality and starting really
makes sense. Thank you guys. All right. I saw a lot of hands go up already, so why don't we go ahead and start with some questions here. Next 10 minutes or 8 minutes here to go. So.
I'm heavily involved in AHR on a bunch of technical committees, so thank you for the props for AHR. I'm a consulting engineer, design, commission hundreds of systems. So how do you guys think you get the data stack of the design intent? Why did I pick a boiler that's 66% load? Why did I go primary, secondary, tertiary pumping? So to me, as you optimize, like you got to fix my mistakes from the get-go. So how do you get that data in?
So that's critical to what we did. So this is where, there's different points of view, and there's needs for both of them, right? Evolutionary plays and revolutionary plays. So you're speaking to the very starting points of why we started Passive Logic, those very questions. If the automation system doesn't understand my system, then we're lost already, right? I can't, an optimizer is not gonna solve the design problem, or the optimizer cannot control the system if it doesn't actually understand the system. And so this is where, from our point of view, we built a piece of software called Autonomy Studio that replaces whatever you're using, Visio, AutoCAD, for your design, and you design it in Autonomy Studio, and you design, here's my system. And what you're telling it, that translates into digital twin, and it can figure out from all the physics of that equipment what each equipment does within the system, and breaks it down into subsystems and understand what each subsystem does. And then from that, generates its control paths and its optimization loops all in one. And so you're pointing to this like core need. This is why you see this big differentiation between optimizers. Optimizers are, you have a control system, it does a thing, you can tweak and tune the variables that are left over, and some of those usually are bad ones to tweak and tune, like you see in most optimizers. They're fiddling with their thermostat. What you don't want to your customers is, I said 72, I walk away, I come back at 68. Why the hell is it 68? I said it's 72, right? That's bad user interface. What you want instead is like people to say, I want this kind of comfort. The system understand what your comfort is and what you're trying to achieve, understand the system, and then be able to control that system based on the fundamentals of the design you gave it, and give you design feedback as well, saying like, well, how about you do this instead of that, right? Those first steps in the design, if they're wrong, you can only optimize or control what is wrong to the best of its wrongness, right? So I think you're hitting on some really key points of how you have to rethink the stack to start at the design.
Well, yes, and you also have to tweak, you don't have to do everything under one vertical silo. As we know, it's going to be hard for everyone to just do passive logic technology and everything, much to Troy's chagrin. But, so
You'll eventually.
No, I know. At 20 years from now, it'll all be
We
passive.
all will assimilate.
So we all will assimilate. But in the case where you're not, the part I brought up about this industry being one of the barriers is that we move so slow. We are so slow to adopt any change. Forget AI, just any change. And so what I've seen is the most successful deployments that mitigate the risk you're talking about, unfortunately, are negotiated design build, where you have teams that are used to working together, used to constructing together, from engineering through design, through integration, through commissioning, and through operations. Because they had operations in mind when they designed the building, when they built it. Too many of our projects don't have operations in mind. They have first cost in mind, and that's it. And so you lose a lot of that context during the build because they're so worried about cost. And they weren't worried about operating cost. They're worrying about right now, how do I construct it? And that's one of the biggest things I think needs to change before we can get anywhere, much less to what Troy's talking about, right? So that's kind of the more immediate thing that I think has to take place now.
Was your question though, like how, and I completely agree, 100%. But was the question like, how are you gonna check my sequence of operations that was right for that area, or?
So part of it is you guys throw out a lot of data, but it's all time series data. But
Agreed.
to me, like the data is that design intent.
Yeah.
Yeah.
Block loads. The
What was the model?
Right.
Yeah.
For the last 20 years, like how do you capture?
Yeah, I mean, that's why you need digital twins. That is your design intent. Like, why does this building exist? Why does this equipment exist? In what, arrangement and configuration?
Those are the guardrails, Troy's, those are the guardrails we have today. Troy's talking about guardrails down in the future where his are dynamic, but yours are the guardrails we have right now that we should be optimizing against.
To be clear, in new construction, it's a no-brainer today, right? There is an argument to be like, the lightweight overlays of existing, infrastructure, absolutely. And, where we are, that's probably not where passive logic is going to play in the next 2-3 years. We're going to make that more available to you. But in today's world, like today, if you're doing a system, passive logic ground up or existing BMS, like it's, to your point, like this is no-brainer. You start with this and, it's similar costs. Why would you not, right?
Okay, David?
Yeah, I'm David Katz, I'm with the Building Intelligence Group. But I've been doing this, looking into this for 30 years. We do neural networks, fuzzy logic, how to run the nuclear stations. I'm getting on an airplane that is autopilot. I hope that Boeing has got the right software. So I think there's an opportunity, but as you said, each building is a snowflake. And so we have to adapt to that challenge. We have the same build. So my question is, and I think you mentioned it about looking at other industries and bringing that capability to buildings, as we're going to hear from your announcement, as we learned on the Smarter Building Summit. So I think we have to learn from other industries. I will also say the lawyers think they're going to get rich. Who are you going to sue? How are you going to prove it? So I think you might have to address that.
I want to say that, yes, each building is a snowflake, but if you dive down deep enough, everything is built of atoms. Every building is built of the same core number system. AI is going to go down deep enough that it's not looking at the building at a whole. It's looking at those number patterns.
But to your point, like I think this is core to our thesis of it's what differentiates buildings from, say, automotive, right? And why I think it's fun to bring automotive people over into the building space, because like over there you made an autonomous car. Here you're going to make generative autonomy, meaning you get to describe your own custom autonomous system for that custom building, because everyone's different. And it is the thing that is unique to our industry that other people don't have.
The purpose of a building changes, unlike a car.
Yeah, and over time.
Every 2 years.
Yeah.
Design questions that our engineer had. One of the big concerns, I think, on the design side is what are the mistakes we want to avoid now so that as AI matures, we're not locked into a non-solution in the future, right? Like everyone can put in mathematics in 08, feels like they're making a big mistake, digital was right around the corner, and now they have all this infrastructure to wait on changes. what can, designers
Sti-
do now?
So
Is that-
I want to get this on the recording. So what are the mistakes we need to avoid now so we don't cause problems later?
Yeah.
Yeah, prevent AI in the future.
Scheme out everything.
Right. I think there's a couple, some of these guys have been talked to about, like, we have to get to, whether or not you're talking about AI, you have to kind of get to modern technology infrastructure, right? So when we think about what did we need to do with our platform, I think there are topics that this industry is behind of how do you have, say, container-based microservices on your end automation platform that you can swap out very readily. A modern platform, right? Like that anybody building technology stack today, that's how they'd approach it. And we're still riding on like C++ embedded systems from the 90s, right? So you're just not, you don't have that flexibility. We need to have the flexibility for, if you have good, modern, adaptable digital infrastructure, you're not changing that whole infrastructure, you're swapping out a microservice and you're giving it new capability. Or it's data-driven, and by the data description of the digital twin change, without any code change, you've given it new capabilities. And so having more fluent systems, I think, is the first step.
All right. Unfortunately, we are at our time, and there's more things coming in here. I should have left 20 or 30 minutes maybe for the Q&A. So thank you for joining today, panelists. Appreciate that. Great job. Thank you in the audience for your time today. On behalf, again, of Automated